take out your highlighter. Today we're going to learn about compound interest, and it's kind of like, it's in the news today. The Bank of Canada raised interest rates again today by another 0.5%. So right now, that means if you owe money, it costs you more to pay it back. But if you have money, the bank account might pay you more interest in your bank account right now. So for students, sometimes this is a good thing, because you're not at the age yet where you're like, oh, I just bought a house. Probably not. Some of you have bought cars, right? And if you buy a car, you might have to pay interest on how much the cost is going to be for that. But for most of you, you're just like saving a little bit of money right now, and if the bank pays you some interest, this could be a good thing. But for your parents, who probably owe money on a house, or owe money on a car, or owe money on all the things that they have to buy for you, then they're like, oh no, my life just got more expensive. Because now it costs more money to borrow. Yeah. So one of the topics that's related to exponentials is something called compound interest. And so here's a little bit about how compound interest works. They say they've got $100 that pays 2% annual interest. This could be possible now. 3 years ago, there would be no banks that would pay 2% interest. That would be really high. I mean, when I was a kid, they had like interest rates sometimes for students like 5 or 6%. But then the cost of borrowing money was even more than it is right now. But if it was paying 2% annual interest, what that means is at the end of the year, 2% of 100 is $2. They would pay you that $2, and you would now have $102. That's how an interest rate works. And that's what 2% interest means. So if you borrowed $100 and you were only being charged 2% interest a year, that would mean at the end of the year you'd have to pay back $102 instead of $100. You'd have to pay a little bit more. Do any of you have credit cards yet? Some of you will get credit cards maybe in your first year of university. Credit cards usually charge around 18% interest. So if you don't pay back your $100, you have to pay $118 for that at the end of the year. And they like to tempt you into doing that. And the way that they tempt you into doing that is you go to a store. You see something you like. You have no money, but you have a credit card. So they're like, yeah, we'll let you buy it, even though you have no money. And you buy it with your credit card, and you're like so happy, because you got a really good deal, right? And then, at the end of the month, they say, oh, by the way, that TV that you bought for $2,000, you owe us $2,000, or you can make a minimum payment of $10. And you're like, sweet. I don't have to pay the $2,000 back. I just have to pay $10. And if you pay that $10, then they say, now we're going to start charging you 18% interest. Right? 18% of your $2,000 TV is $360 more at the end of the year. So even though you got a good deal on that TV, if you don't pay it off, you're going to end up paying a lot more for that TV. I read somewhere once that the average, I think it was an American statistic, that the average American pays $300 for every $100 they spend on their credit card, which is triple the amount. So when you buy something with your credit card, you say to yourself, can I afford to buy this for 3 times the amount that it is? Or you have to be very self-disciplined and say, if I buy it on my credit card, I need to make sure that I pay for the whole amount at the end of the month. Because then credit cards have advantages, right? Some credit cards give you points. I have a credit card that gives me money. It pays me money for using it. So every time I spend $100, they say, thanks, here's $2 back. And if I pay it back, then the $2 is mine to keep. If I don't pay it back, they say, here's $2, now you pay us 18. Then it's not so good anymore, right? Then it's not as good of a deal. Now, what does compound interest do? Compound interest says, well, if you leave this in for more than a year, at the beginning of the next year, you now have $102, and so at the end of that year, they're going to give you 2% of this, which 2% of the 100 is another $2, but now you also make 2% on the $2, and you would have $104.04. Really exciting. So not only did you make the 2% $2 again, but you made an extra 4 cents as a result. And the next year, you would make 2% on the 100 again, but you'd also make 2% on the $4.04, which would give you another 8 cents. Now, compound interest, if you leave it long enough, is exponential. And exponential graphs start to go like this. So at the beginning, these extra few dollars, extra few cents doesn't make a lot, but over time can really make a lot of money. So when you make an investment, it might have compound interest. And when you get a loan, it likely has compound interest as well. So what we're going to see in this unit is how those things are going to affect you, because you will probably, most of you, will buy a car sometime in your lifetime. And most of you will buy a house sometime in your lifetime. And some of you are just like, I'm going to just live in my car. Except for today would have been really cold overnight. And what if you would have turned it on? It's a lot of gas. I know that'd be kind of expensive. Gas is expensive. Okay. So that's compound interest. The idea of it. There's a formula given here. I'm also going to get you to write this formula. Some textbooks have it written this way. And in this unit, there are lots of formulas for compound interest, for earthquakes, for decibels, and none of those formulas are on your formula sheet, which at first sounds scary. Do you have to memorize them all? No. They made a change a couple of years ago. They said, instead of putting the formulas on your formula sheet, whenever we ask you a compound interest question, the formula will be given in the question. So the reason they did that is now any formula is possible, even if you haven't seen it in class. You could get a question on a test with a new formula you've never seen. You just have to be able to use formulas and know how they work. And every time a formula is given to you, they will tell you what things stand for. The principal. So in this formula, the principal is A0. In this formula, the principal is the letter P. So that's your starting amount. Is invested at an annual interest rate of I, or in this formula R, with n compounding periods. Now when we're talking about a compounding period, this is how many times they pay you interest. So a really simple example, if I had $1,000 and it was paying 10% interest compounded monthly, what that would mean is at the end of 1 month, they would say, well, normally in a year, 10% of 1,000 is $100. But if it's compounded monthly, at the end of 1 month, they would say, you are eligible to receive 1 month's worth of that interest, which is 1/12 of $100. So at the end of month 1, 1/12 of the $100 is $8.33. They would give you $8.33. And then at the end of month 2, they would say, oh, 10% of this amount is $100.83. You are now eligible for a 12th of that. A 12th of $100.83 would be another $8.40. So the first month you got $8.33 of interest. The second month you'll get $8.40 of interest. And the next month you'll probably get $8.49 of interest. So your interest that you get each month gets bigger because it is compounding more often. So the number of times it's compounded in a year is in the formula as n. Okay? A is the total amount after t years, so t is time in years. And we will look at a question with compound interests. So a principal of $1,500 is invested at 4% annual interest, compounded quarterly to the nearest quarter of the year. When will the amount be $2,500? And you would be given either form of the equation with the explanation. So what we have to do as a starting point is we have to put in all of the values. So we want to, a principal of $1,500, so we know that the initial amount is $1,500. Interest rate as a decimal, so 4% would be 0.04. Compounded quarterly, quarterly means 4 times a year, so n is 4. We want to solve for t, and when will the amount be 2,500? And so we have what we want to solve for in the exponent. And at this point, we have learned that you can solve for an exponent if you can get the bases the same on both sides. But unfortunately, do these look like numbers that are on your powers chart? No. So we are going to learn an algebraic technique to figure this out once we learn logarithms. But at this point, this is a Desmos question or a graphing calculator question. So if you had to solve an equation on your graphing calculator, you could put the one side into y1, put the other side into y2. Same thing in Desmos, you could make 2 equations. And then look, where do those 2 equations cross? I can draw a quick sketch here. I know that this equation at 2,500, I'll draw it in green. That would just be a horizontal line at 2,500. This one is an exponential graph. So it will look something like that. This is what we are trying to find. Where do they intersect? And then we would be able to solve for t. So take out your graphing calculator or Desmos and see if you are able to 12.75. Get that intersection to be at 12.75. It says to the nearest quarter of the year, so it probably comes out to 12.8 or 12.7, and you would have to round it to 12.75 to the nearest quarter of the year. want to circle questions 12 and 13.